Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the check if the sentence is pangram problem. A pangram is a sentence where every letter of the English alphabet appears at least once. Given a string sentence containing only lowercase English letters, return true if sentence is a pangram or false otherwise. So, for example, if we're given the sentence, the quick brown fox jumped over the lazy dog, all one word. This is a pangram in English because we have A, B, C, D, E, F, so on and so forth, all the way down to X, Y, and Z. Every letter occurs at least once. Therefore, this is true. Here we have, well, we immediately can see we have no A's, so this is not a pangram. This is a easy problem. I'm not going to lie, the difficulty easy is well deserved here. But there are lots and lots of ways to approach it. So one option might be to, say, create a dictionary. And then what you can do is you can say, well, as I go through the letters, I'm going to increment the count of each letter in the English alphabet by 1. So you initially start the dictionary with all of the letters that you care about, initialized to 0. If you come across something that isn't in your dictionary, well, that's a problem. But thankfully that is not allowed by the constraints of the problem. And then what you do at the end is you go through your dictionary again and you say, well, are these greater than or less than 0? Oh, sorry, are they greater than 0 or are they equal to 0? If they're greater than 0 for every entry, then you're done. But we only really care about that predicate case, and we immediately know whether something has a count greater than 1 or not on the first occurrence of it. So rather than having to store the count, we can just sort of store a have seen boolean. So have I seen this thing before? They're initially all false, and then when we see it, we set it to true. So this is a dictionary mapping to true and false. A good way to model a dictionary that's actually mapping true and false, or perhaps more accurately, what a dictionary mapping to true and false models, is a set. So a set is basically, it contains some elements. If they're there, it's true. If they're not there, it's false. So we can create a set of all of the letters in our word and check that every letter of the alphabet is in that set. So this here would create the set equivalent to A, B, C, D, yada, yada, yada. And then we could say, well, is A in there? Yes. Is B in there? Yes. Is C in there? Yes. Yada, yada, yada. Whereas here, we would end up with a set equivalent to C, D, E, L, T, O, something like that. Then we can ask, is A in here? And we'd get a no. A is not in this set. We can go even further though, because we know exactly how big this set can get, because we know there are 26 unique English letters. So and because everything is made of those 26 letters, the set can get at most 26 characters long. But we also know that to have used every character, the set must be at least 26 characters long. So it can be at most 26 characters long. It must have at least 26 characters. So therefore, we actually are interested in, is the set of all the letters used in the sentence of size 26. So putting that all together, return 26 is equal to the length of the set of the sentence. Let's run this. Amazing. That is it. That is the entire problem. This is another one that's really, really slick to do in APL. So over here, I've got the same problem loaded up for APL. And we can say, is 26 equal to the size of all of the unique characters in the input So if we run this with this, this is true. Whereas if we run this with Leetcode, it is false. This is our solution here in APL, here in Python. Yeah, it's going to be pretty concise in most languages. I guess if you tried to do it in something like C, you'd have the problem of defining a set. Although, in fact, let's do it in C as well. Bool letters 26. It starts off at 1, 2, 3, 4, 5, 6, 7, 8. It's probably all initially 0. I think that's what we want anyway. So then it is for, in fact, for car C. How do I do this? Char C while C, hang on, is equal to sentence 0, while C does not equal the end of the string. How do I want to do this? No, I need to do this slightly differently. I can do it like this. I can do it with char star C is equal to sentence, and then do it with C++ on the end, not that kind of C++. And then what we want to do is we want to do letters. What we want is the value of C minus A equals letters value of C minus A. Now you might be asking, why am I doing this minus A business? Well, that's because A is, I don't know, like a 97 or something in ASCII, but here we just want to do 0 through 25. So we do a little subtraction to move things into the right range. In fact, I can just say that's true. I don't need to do anything fancy there. For int I equals 0, I is less than 26, I plus plus. If it is not letters I, show false. If we get all the way to the end, return true. Let's try that one. In fact, no, let me do a quick check. So this should get filled with falses initially, I believe. And then what we want to do is walk through our sentence while the sentence is valid. And we're going to say, well, the letter I'm currently looking at, I want to say I have seen it. Keep going. And then here I want to go through all of the letters and just say that if that letter has not been seen, it's not a pangram. If we get all the way to the end, it must have been a pangram. Run the code. Excellent. We can submit that. Oops, I forgot to submit my Python version. Anyway, all the same kind of business. Let's quickly do the Python one. Excellent. Obviously, it's exactly the same algorithm. The C one is a little different because the set here is much more implicit. and the length of it, we need to actually check that all of the things are true. So this is more like our hash map example that we discussed first, mostly because C doesn't have nice data structures built in. If we were to do this in C++, I would probably use something like standard set or cars or something like that to build up a map, a set of the characters we have seen, and then check that its size is 26. And we also saw the very, very slick little APL solution. Anyway, that is it from me. Do remember to like, comment, subscribe, all of that good stuff for an easy problem. This was a bit of a rambling one. Sorry about that. But I do hope you enjoyed, and I will see you next time. Bye.